We're going to take a look at the power of a product property. Now, the way that the textbooks describes how to find the power of a product property is find the power of each factor and multiply. Now, for me, I don't find this description terribly illuminating, so let's look at some examples. Our first example will be 3 times 2 squared. Now, if you were to solve this using what I characterize as our conventional methods that you understand so far, you would say, well, I know that 3 times 2 is 6. So inside my parentheses, I have a 6, and then I can do 6 squared, which gives me 36. And that's all fine and dandy, but there's going to be instances in which multiplying what's inside the parentheses isn't going to work. And for that, we can use the power of a product property. So this is how we would use that. So rather than multiplying the two things inside the parentheses first, we're going to take each factor, each part of what's inside our parentheses to our exponent. And what this looks like is we now have 3 squared times 2 squared. 3 squared is 9, and 2 squared is 4, and 9 times 4 is equal to 36. As you can see, the power of a product property is equally valid as evaluating what was inside our parentheses first. And in many instances, it's simply not possible to actually multiply what's inside our parentheses and get a single factor, that's 6, like we had in this example. If we had inside our parentheses instead, say negative 3x cubed on the outside, we obviously can't multiply negative 3x together. They're already multiplied together, and even if they're not, it's just negative 3x. So we can take each factor inside our parentheses to that third power. And that would give us negative 3 cubed times x cubed. Now, negative 3 cubed is negative 3 times negative 3 is a positive 9 times another negative 3 is negative 27. And x to the third, or x cubed, is x to the third. If we just had variables inside of parentheses, it would proceed in a very similar way. For example, x times y to the fifth can be very quickly evaluated as being x to the fifth times y to the fifth. So in each one of these instances, our power that's on the outside comes down and now becomes a power on each thing that's inside the parentheses. Now, there's a couple of things you're going to want to watch out for on this. The first one is the power of a product rule does not work for something like this. This does not equal x cubed plus y cubed. The power of a product rule only works if we have a product, meaning if the things inside are multiplied by each other. The second thing I want to dissuade you from doing, and I'm sure you've already seen this as being a possible error, but if you have x times y squared, do not take the exponent down and multiply so you end up with 2x times 2y. This is also not a true statement, although hopefully you've seen enough examples of this. Now, there's just one more example I'd like to go over here, and this one combines one of our earlier rules, so it's going to be a little bit tricky for you. And in this example, what we're going to have is we're going to have 2 times x squared cubed. So in this one, we're just going to apply the rule again. We're going to take our exponent down and we're going to put it around each of the things. I'm even going to put them in parentheses like I did in this one so you can see exactly what's happening. We have 2 cubed times x squared cubed. So 2 cubed we can pretty quickly figure out is just 2 to the third, which is 8. But x squared to the third, we need to remember, oh, wait a minute, this is our power to a power rule. When we have the power to a power rule, we need to multiply the powers by each other. So this becomes x to the sixth. All right, you should be ready to look at a couple of examples here.